So hello guys, welcome to my YouTube channel Med School with Shubham. I am Shubham, a third professional MBBS student, and I shall be teaching you anatomy. I have started a new series on embryology on my YouTube channel, in which I have completed the first week of development and the second week of development. Today we shall be starting with the third week of development, and this is the part 1 of the third week of development. The most important thing that we have to learn in the third week of development is the trilaminar germ disc formation. The third week of development is also called as the week of gastrulation. What other things that we shall be learning in this week are the notochord formation and the process of neurulation or the neural tube formation. So let's first start with the trilaminar germ disc formation, or we can also call it as gastrulation. So what actually is gastrulation? So gastrulation is the conversion of the bilaminar germ disc to trilaminar germ disc. We studied in the second week of development that in the second week of development we studied the bilaminar germ disc formation. So now in the third week of development we will be studying the trilaminar germ disc formation. Means what? In the second week, the bilaminar germ disc will develop into the trilaminar germ disc. So this process is called as the gastrulation, and it occurs in the third week. Therefore, this week is called as the week of gastrulation. Okay. So let's start with the week of gastrulation. Okay. So I shall be drawing the same diagram again. This is the epiblast. Okay. These are the amniogenic cells. Guys, if you have not watched my previous lectures of embryology, I request you please go on my YouTube channel and please watch the previous lectures which I have covered on the first week of development and the second week of development. Unless and until your first and the second week of development, your concepts are not clear regarding that, you won't understand the further things that I shall be teaching you in this lecture. Okay. So this is the epiblast and the amniogenic cells, and this is the hypoblast, and these are the Users membrane. I hope you remember this thing, or else let me take you to this diagram again. Okay, see, I have drawn the same diagram. I have taken this part, the epiblast and the hypoblast and the amniogenic cells and the Users membrane. The same diagram in this form I have drawn over here. Okay. Now what happens? The first change that will take place is towards the hypoblast side. First let me name this. This is the epiblast and this is the hypoblast. Towards the hypoblast side, this is the towards the hypoblast side, what will happen? If this is going to be a cranial end and this is going to be the caudal end, assume that this is going to be the cranial end, means the head of the baby will be forming in this end and the tail will be forming in this end. So near to the cranial end, some hypoblast cells will get differentiated. These are lower cuboidal or squamous like cells. They will get differentiated to form columnar like cells in this manner. Okay, so we will get a structure like this. These are the hypoblast cells. So the lower cuboidal will get differentiated into columnar cells only in a small patch-like manner. Not the entire hypoblast will get differentiated, but only small part of the hypoblast. Only in this manner, only in this place, they will get differentiated from lower cuboidal to the columnar like cells. So this is the first change that we can see. Now what is the next change that we can see is, now we saw the change in the hypoblast side towards the cranial end. Now we will go opposite of that, means the first thing that we will see the change now in the epiblast side and towards the caudal end. The cranial end means the head end and the caudal end means the tail end. So we saw the change towards the cranial end but on the hypoblast side. Now we will see the change towards the caudal end but towards the epiblast side. So what happens in the caudal end? The cells near the caudal end, these are the columnar like cells of the epiblast. What happens? Some cells of the epiblast towards that are near to the caudal end, they will get differentiated to form small globular like cells in this manner. Globular like cells, and they will start growing in this direction, that is from caudal end to the cranial end. And now when they reach the midpoint, of the embryonic disc, they will form a globular like structure in this manner, or they will form a node, okay, and the rest will be the same thing. Okay, so let's name them. So this structure that we have made here, it is called as the precaudal plate. Precaudal plate. It can also be called as the procaudal plate. The precaudal plate or the procaudal plate. The next thing is this one. It is called as the primitive streak. Primitive streak. What is primitive streak? So towards the caudal end, but on the epiblast side, towards the caudal end but on the epiblast side, the columnar cells of the epiblast, they gets differentiated into the small globular like cells, and they will migrate towards the head end or towards the cranial end. This is called as the primitive streak, and this thing, it is called as the primitive node. Primitive node. It is also called as the Hansen's node. The primitive node or the Hansen's node. Okay. I hope you have understood all these things. So let's revise it once again. So these were the epiblast and these were the hypoblast. So the first change we will see in the hypoblast side, but towards the cranial end. Means the smaller cuboidal like cells, the lower cuboidal like cells, they will get differentiated. The lower cuboidal like cells, they will get differentiated into columnar like cells, means cuboidal cells or the squamous cells, they got differentiated into columnar like cells, and this is called in the form of a small patch, and this is called as the precaudal or the procaudal plate. Now what will happen opposite of that, means this was on the cranial end, now next thing will happen on the caudal end. This happened on the hypoblast side, the next thing will happen on the epiblast side. So this was near to the cranial end, now the next will happen near to the caudal end. So it started differentiating, the columnar cells will get differentiated to form small globular like cells, and they shall migrate towards the cranial end in this direction. They shall migrate towards the cranial end, and now when they reach the midpoint of this plate, they will form a node like structure or a tumor like structure. You can also say it as a tumor like structure, which is called as primitive node, and this line is called as primitive streak. Okay. So now let's make one more diagram with which your concepts will be more clear. So this is the embryonic plate. Okay, this is the embryonic plate. Now the first thing that we can see is the so towards the cranial end we will have the formation of the procaudal plate or the precaudal plate. Next, towards the cranial end or caudal end, we will have the formation of this primitive streak in this manner. And then when it reaches the midpoint towards here, it will form the primitive node or the Hansen's node. Okay, so let's name them. This is the procaudal plate and this is the procaudal plate, and this is the primitive streak, and this is the Hansen's node. I hope this is very clear to you guys. So let's move forward. I hope this was very clear to you guys. So let me explain you this same diagram once again. So assume this is the embryonic plate, embryonic disc, and this is the cranial end, this is the cranial end, and this is the caudal end. So first we will get the formation of this procaudal plate, which is towards the cranial end. Then towards the caudal end, in the midline, we will get the formation of the primitive streak, which will grow from the caudal end towards the cranial end. And when it reaches the midline, it will form a node-like structure, a nodular mass, which is called as the primitive node or the Hansen's node. Okay, so let's name this. This is the procaudal plate. This is the primitive streak, and this is the primitive node. Now what is the significance of this procaudal plate, primitive node and primitive streak? So first let's know the significance of primitive streak. So now what will happen? This primitive streak will now start proliferating, and then it will replace all the epiblast cells and all the hypoblast cells, and then it will form the definitive ectoderm. First it will replace all the epiblast cells. Means what? So your primitive streak was there, it will start proliferating, and then let me show you. It will start proliferating the cells over here in this direction, and then it will replace all the epiblast cells, and now it will form the definitive ectoderm. Till this point, I hope you remember that I named the epiblast as the primitive ectoderm. So now this is the new thing we will be forming is the definitive ectoderm. The next thing which will be forming is the intra-embryonic mesoderm. Mesoderm means once the primitive streak has replaced all these epiblast cells, that is now it has formed the definitive ectoderm. Now primitive streak will now proliferate the cells between this epiblast and the hypoblast, between this space, and now it will form a new layer which is called as the intra-embryonic mesoderm. In the second week we learned about the extra-embryonic mesoderm. Here we will be forming the intra-embryonic mesoderm, and the third thing which it will form is the definitive endoderm. So we had the primitive streak, and this primitive streak will proliferate, and then it will replace all these layers. This primitive streak will proliferate, and then it will replace all this layer, and then first it will form the definitive ectoderm, then it will form the intra-embryonic mesoderm, and then it will be formed the definitive endoderm. I hope this was very clear. So this is the process of gastrulation. Let's learn one more thing, that is the bilaminar region in the trilaminar germ disc. Means what? This primitive streak, we learned that it gave rise to the definitive ectoderm, the intraembryonic mesoderm, and the definitive endoderm. But there are some places where the primitive streak does not form the mesoderm. So those region which are devoid, those region which are devoid of mesoderm, or you can say those region where the mesoderm is absent. Mesoderm is absent. Those regions are called as the bilaminar region in the trilaminar germ disc. Means in that region you will only find the ectoderm and the endoderm, but the mesoderm will not be present in those regions. So there are two such regions in the trilaminar disc. The one is at the cranial end, and the one is at the caudal end. The region in the cranial end where only the ectoderm and endoderm is present but the mesoderm is absent, that region is called as the buccopharyngeal membrane. Buccopharyngeal membrane, and that region which is at the caudal end, which has only ectoderm and the endoderm but the mesoderm is absent, that is called as the cloacal membrane. Okay. Now this buccopharyngeal membrane is further going to form the oral opening or the mouth opening. And the cloacal membrane is further going to form the anal opening. Now this buccopharyngeal opening will break down to form the oral opening. So that breakdown will take place on the 4th week of development, and the cloacal membrane will break down to form the anal opening, and this breakdown will take place on the 7th week of development. I hope this is very clear to you guys. So let's revise everything once again. So in this lecture we learned about the trilaminar germ disc formation and the gastrulation. What is gastrulation? Gastrulation is a conversion of bilaminar germ disc to trilaminar germ disc. Means in the 2nd week of development we learned that there are 2 germ layers, therefore bilaminar germ disc. But in this week 3 germ layers will be formed, therefore trilaminar germ disc will formation. And this process is called as the gastrulation. Therefore this week is also called as week of gastrulation. This was the epiblast, this was the amniogenic cells, the hypoblast and the Users membrane. So on the hypoblast side, some lower cuboidal cells, they got differentiated into columnar like cells. Okay, and this is called as it is formed in the form of a patch. This is called as a precaudal or a procaudal plate. Formation of a precaudal or procaudal plate is the first sign of the head end. Keep this in mind. First sign of head end means what? If the precaudal plate or the procaudal plate is formed in this side, this end, near to this end, then this is going to form the head end and this is going to form the tail end. But if it is formed at this side, then this is going to form the head end and this is going to form the tail end. Therefore, it is said that precaudal plate formation is the first sign of the head end. Next, what did we see? That is now on the epiblast side, but near to the caudal end, the columnar cells got differentiated into smaller globular like cells and they migrated towards the midpoint or towards the cranial end. So while migrating towards the cranial end, when they reach the midpoint, they form a nodular mass-like structure. And this mass-like structure is called as the primitive node or the Hansen's node, and this line is called as the primitive streak. Okay. Now let's move forward. This primitive, so this is the procaudal plate, this is the primitive node, and this is the primitive streak. So the primitive streak gave rise to definitive ectoderm, intraembryonic mesoderm, and definitive endoderm. Now next thing, The bilaminar germ region in the trilaminar disc means what? The region which is devoid of the mesoderm means what? The mesoderm is absent in that region. Only ectoderm and endoderm is present. So it is present at the cranial end and at the caudal end. The one which is at the cranial end is called as buccopharyngeal membrane, and the one which is at the caudal end is called as the cloacal membrane. The buccopharyngeal membrane will open to form the mouth opening. The buccopharyngeal membrane will form the mouth opening or the oral opening, and the cloacal membrane will form the anal opening. So the mouth opening or the oral opening will be formed on the 4th week of development, and the anal opening will be formed on the 7th week of development. I hope this is very clear to you guys. So this was about the process of gastrulation. In the next lecture, we will be learning about the notochord and formation of the notochord. So thank you guys for being with me till this point. Please like my video, share my video, and also subscribe to my YouTube channel. Thank you so much guys.